Now, let us see the next set of questions. These are useful for the upcoming Telangana TSSPDCL sub-engineer exams, as well as AE exams, as well as ECET and all other the PSU exams, etc. Right? These are substandard questions actually. These are not up to the standard of GATE, but these can be used for PSU exams also. Right? Now let us see the question. A 3-phase 6-pole 50H induction motor has a slip of 1% on no load and 3% at full load. Okay. So he gave number of poles as 6 pole, frequency as 50H and slip at no load is 1%. So it can be written as 0.01 and slip at full load. It is given as 3%. It can be written as 0.03. Then he asked, find the no load and full load speeds. Right? He is asking, find the no load and full load speeds of rotor. It should be find the no load and full load speeds of rotor. Right? This is the question. Now, let us find the no load speed first. Rotor speed is generally given as NR is given as NS into 1 minus S. Right? Direct substitution. What is the value of synchronous speed? We need synchronous speed here. Synchronous speed, we already know the formula is 120 F by P. Done. 120 into 50 by 6 will be 1000 RPM. Right? So generally, please do remember these things because we won't get time to calculate this all silly things. Right? For 50H 2 pole, it will be 3000 RPM. Synchronous speeds, 4 pole it will be 1500 RPM and for 6 pole it will be 1000 RPM and for 8 pole it will be 750 RPM. What is for 10 pole? What is for 10 pole? It should be 600 RPM. These are the synchronous speeds corresponding to 50H, right? 120 F by P. If you do this, we will be getting, right? Now directly substitute. Now we got 1000 into 1 minus 0.01. This should be 990 RPM, I think, right? This is 0.99 into 1000. It is 990 RPM. Now let us see the full load speed. Same thing. NS into 1 minus S. Slip is 0.03 here. (970 RPM). 1 minus 0.03 is 0.97 into 1000 is 970 RPM. If you see clearly, the rotor speed is decreased from no load to full load because load is increasing. Since the load is increasing, speed will reduce. That is what is happening here. If you see clearly, this is the best example for this statement. Right. Now let us go to the next question. Which one of the following is wrong with respect to SF6 gas? Okay. He took from protection. Okay, fine. Okay. All these are properties of SF6 gas. Properties he is asking. Dielectric strength is 2 to 3 times that of air. Right. For SF6 gas, dielectric strength is very high and that is 2 to 3 times that of air. This is correct statement. But he is asking for wrong statement. Low maintenance cost. This is right. That is why we use SF6 gas actually. It is used for all range of voltages. It is used for circuit breaker protection. This is generally comes under circuit breaker protection, and SF6 circuit breaker is one of the circuit breaker, and this circuit breaker is used for the protection of all range of voltages actually. So because one of the advantages, it is maintenance cost is also very low. And next point, highly inflammable. This is wrong because SF6 gas is highly non-inflammable actually. And last, noiseless operation. This is right. This is noiseless. So 3 statements are right and 1 is wrong. So this is the answer. C, option C is the wrong statement. The correct statement should be, it should be highly non-inflammable, and all these are properties of SF6 gas. Because of having all these advantages, we are going for SF6 gas for circuit breaker operation. Also, one more point to be remembered is it is highly electronegative in nature. SF6 gas is highly electronegative in nature. Electronegative in the sense it can absorb electrons very easily. That means it absorbs electrons very easily. This is the one of the most important point, and this helps in arc extinction of in circuit breakers. Actually, I mean arc extinction in power system protection. This electronegative nature is the most important point corresponding to SF6 gas. Right? This is the answer. Answer should be highly non-inflammable actually, but he gave highly inflammable. So this is the answer. Let us go to the next question. The instantaneous relays have an operating time less than, okay, operating time less than, okay, fine. This is a typical question actually, typical value question. This should be remembered like this only, because if you see clearly, instantaneous relay have an operating time less than. If you see clearly, this is under I mean we can clearly say that this is subtransient period. This comes under subtransient period actually. So generally relays and circuit breakers should be operated in transient period. So answer should be 0.1. No other options are matching. 1 second and 10 seconds. These are very high time periods actually. Very high. Initially we will be getting subtransient period, then transient period, then steady state period. So this is very long, very long. So here we cannot operate, and this is the only possible zone. So generally all the circuit breakers will be operating in this region. And here he gave instantaneous relay. This is absolutely right. 0.1 is the right answer. This is a typical value. Please do remember this thing. Next, the exchange of conductor positions in transmission lines to regain its symmetry. Okay, fine. So okay. He is saying that the exchange of conductor positions at regular intervals should be written. If he gives at regular intervals to regain symmetry. This is transposition. This is from power system transmission and distribution. Where is done? This is the answer. Remaining all are waste. This is the correct answer. Transposition. Generally, for conductors, we will be displacing after every 1/3 of length. We will be displacing the conductor like this. Like this, we will be doing. Then we will be bringing here. Then we will get here. Like this, we will be displacing the conductor after every 1/3 of the length in order to equalize the flux distribution, non-uniform flux distribution. Equalize. Generally, communication interference is a problem. Actually, we will be seeing whenever a power line comes in contact, I mean very near to a communication line, then we can see non-uniform flux distribution that leads to communication interference actually. And that communication interference can be minimized by transposition. This is a phenomenon. I mean this is the way of transposing. This is the way of transposing a transmission line. If you regularly displace the transmission line at equal intervals of time, and I mean at a regular lengths, then we call this phenomenon as transposition, and this is used to minimize communication interference. This is also one of the important bit corresponding to transmission line, power system transmission and distribution. Fine, let us go to the next question. Sag of an overhead line is directly proportional to square of length of, okay, inversely proportional to weight of conductor, inversely proportional to length of span, directly proportional to tension. Okay, fine. Let me write the equation for sag. Sag generally is W L square by 8T, where W is called weight of conductor, L is length of the conductor, T is the tension. Length of the conductor, and this is weight of the conductor. So we can directly see sag is directly proportional to square of length. Inversely proportional to weight, but it is directly proportional. So this statement is wrong. Inversely proportional to length, so not correct. Directly proportional to tension, but it is inversely proportional to tension. So this statement is also wrong. So the correct statement is directly proportional to square of length of span, or correct. Then next, which of the following is the high resistance method of arc extension? Okay. He is asking regarding which of the following is the high resistance method of arc extension. Generally, we have 5 methods for high resistance extensions actually. First thing is lengthening the arc. For arc extension, we have high resistance and low resistance actually. Low resistance method and high resistance method. In these two, high resistance method, we have 5 sub methods: lengthening the arc, splitting the arc, cooling the arc, constraining the arc, and the last one is reducing the cross-sectional area of arc. So let us see the options. High resistance methods: lengthening the arc, fine; splitting the arc, fine; cooling the arc, fine; reducing the cross section. So all are correct. So which of the following is high resistance method? All are correct. And low resistance method is also known as current zero interruption. Most of the questions will be from high resistance method only, but please do remember that low resistance method is also known as current zero interruption, because this is applicable for AC circuit breakers actually, and this high resistance method is used for HVDC or DC circuit breakers actually. This high resistance method is used for DC circuit breakers, but this low resistance or current zero interruption is used for AC circuit breakers only, because we can see natural zero points only in AC, but in DC we cannot see any natural zero points because it is constant all over the time. But here we can see 2 natural zero points in a cycle. In AC we can see 2 natural zero points in a cycle, and at this point of time we extinct the arc. Arc is extincted at this point of time, that is current zero instant. So this is the correct answer. Fine. Now, which of the following is wrong with respect to a synchronous mission? Okay, synchronous mission. Okay, fine. It is a doubly excited mission. It is doubly excited because stator needs separate AC excitation. Stator needs AC excitation and rotor needs DC excitation. So doubly excited. Damper winding is mounted on the rotor. Correct. Obviously right. Damper winding is mounted on rotor itself. Armature winding is energized by DC source. Wrong. It is energized by AC source, because in DC mission we will be having rotating armature. That is, armature will be placed in the rotor. But when it comes to synchronous mission, armature will be stationary armature. That is, armature will be placed on stator actually. There are many advantages of placing armature on stator. Why we will be placing armature on stator and all, we have different conditions and different advantages. I mean that you can study. But armature is generally excited by AC, because stator is excited by AC now. So armature is excited by AC source. And here rotor can be salient pole and synchronous. Correct. Obviously, synchronous mission, they have 2 rotors actually. One is salient pole and the other is cylindrical. Fine. This is correct. So the correct answer is armature winding. Wrong statement is armature winding is energized by DC source, and the correct statement is armature winding is energized by AC source. This is the explanation for this, right? Let us move to the next question. If receiving end voltage is greater than the sending end voltage in the transmission line, the effect, okay, fine, Ferrand effect. Without any second thought, it is Ferrand effect, because magnitude of receiving end voltage should be greater than the magnitude of sending end voltage, and this is Ferrand effect without any doubt. We can go with that. No other option is matching. And some more points to be remembered is Ferrand effect is generally seen in medium and long lines only. In short lines, what is the reason for Ferrand effect? Capacitance. So in short lines, since there is no capacitance effect, Ferranti effect is absent. These are some of the points corresponding to Ferranti effect, some of the important points. And this is the statement regarding Ferranti effect. Fine. We can see this Ferranti effect only in medium lines as well as long lines, but not in short lines, because Ferranti effect generally occurs due to the presence of capacitance, and this capacitance is absent in case of short line. That is why we can't see any Ferranti effect in the short line. Fine. Let us go to the next question. Steam power plant uses dash alternators. Simple, simple, simple. Where is this? Steam power plants. The alternator used for steam power plant should be high speed alternators. Also, this is applicable for nuclear also. For these two, we need high speed alternators, and axial length should be large with a small diameter. So we will be using cylindrical rotor alternators only. But when it comes to idle plant, we need low speed alternators. That is, this alternator should have a characteristic that it should have large diameter with a small axial length. With a small axial length. So because of this characteristic will be possessed by only salient pole rotor. So that is why in salient pole rotor we will be using low speed alternator, that is salient pole alternator, and for steam power plant as well as nuclear power plant we will be using high speed alternator, that is cylindrical rotor alternator, and the cylindrical rotor alternator will have large axial length with a small diameter, whereas the salient pole alternator will have large diameter with a small axial length, and diameter can be written as 5 to 7 times of length here, and here length can be written as 5 to 7 times of diameter. Axial length, I mean the shaft length will be very, very longer when compared to diameter. But here diameter of shaft will be very high. That is why due to stress and all, mechanical stress and all, it rotates with low speeds only. So here, since we use steam power plant, we will be using cylindrical. Salient pole will be used for idle only. This cylindrical can also be used as nuclear also. For nuclear also it can be used, and for thermal power plants also it can be used. Fine. Induction, so not needed. Induction alternator is not there, so we can avoid this. Next, wrong statement corresponding to PMMC. Wrong statement corresponding to PMMC instrument is okay, fine. It uses eddy current damping. Yes, because PMMC generally uses, it measures only DC values actually. So DC values are average values. So the magnetic field produced will be very strong in nature. So for strong magnetic fields we will be using eddy current damping only. Fine. So for PMMC we will be using eddy current damping. It uses spring control, right? Obviously correct. That is why for a PMMC ammeter or PMMC voltmeter, the scale will be linear. Here for one question I am covering around 5 to 6 points. Please do remember this also. And it has high accurate. For DC measurement, this is more accurate actually. PMMC is accurate. Last, it is used for AC. Okay, AC measurement only. He is saying it is used only for AC measurement. But I already said it is used only for DC measurement or average value measurement. So this statement is wrong statement. So we need wrong statement. So this is the correct answer. So we can modify this statement as it is used for DC measurement only. This is the correct statement. Option D is right here. Right? Let us go to the next question. Binary equivalent to 51. Okay, he gave one decimal number and he is asking for binary equivalent. Simple. Right? Divided by 2, we will be getting 25 with a remainder of 1. Then divided by 2, we will be getting 12 with a remainder of 1. Then divided by 2, we will be getting 6 with a remainder of 0. Then divided by 2, then we will be getting 3 with a remainder of 0. Then we divide it by 2, we will be getting 1 with a remainder of 1, right? 2 into 1 plus 1, we will be getting 3, right? This is right from here. 1, 1, 0, 0, 1, 1. This is the binary equivalent. That's it. 51 in decimal will be equivalent to 1, 1, 0, 0, 1, 1 in binary. Done. This is the answer. Next. Which of the following is not an application of split phase induction motor? Okay, resistance split phase induction motor he asked, and he is saying that which of the following is not an application? Not an application. So small drills. This is an application of split phase motor. Mixers we generally use. Washing machine we generally use, and traction system. For traction system we generally use series motor. In DC we use DC series motor, and for 3-phase we use 3-phase induction motor. But single phase induction motors are not used for this series motor. I mean for this traction system. Single phase, especially he gave split phase induction motor. This is not at all used for traction. So we can blindly go with this option. Rest all are used for applications of split phase motor actually. But this is not an application, right? And here we have covered 1 point, 2, 3 points we have covered. So please do remember these points also. Around this question we have covered, see this here we have one point. Here we have covered one question, 2, 3, 4, 5 to 6 points we are covering here. So please do remember these points also. Next, a 8-pole lap wound DC generator has armature conductor 900 armature conductors. Then flux per pole is 40 milliweber. Okay, then he gave speed. Okay, 400 rpm. Then he is asking for EMF. Okay, very easy question, very easy question. EMF generated is pi z np by 60a. So substitute 40 into 10 power minus 3. Z is 900. This is 400. P is 8. 60 into armature parallel paths. For simplex lab it is A equal to P, right? For lab it is A equal to P, that is simplex lab. So number of poles is 8. Cancel it. Then we will be getting, what is answer we will be getting? 0, 0 gets cancelled. 3 2s are 3 300s are, and 2 1s are 2 20s are. We will be getting around 6 4s are 24. So we will be getting around 240 volt. This is the EMF generated in this DC generator. This is the way of calculating, right? So for lab it is A equal to P. If the question given is wave, then it should be A equal to 2. Armature parallel path is 2. This is for simplex lap and simplex wave. Please do remember these 2 points are valid for simplex lap and simplex wave. And if it is duplex, let me write for multiplex actually. Let me write for multiplex lap. It is A equal to NP. N corresponds to what is the plex number? I mean duplex or triplex. If it is duplex, then it is 2, and it is when it is triplex, it will be 3. Simple. For wave, it is A equal to 2n, where n is we already said. For duplex it is 2, for triplex it is 3. This is the way of calculating number of armature parallel paths for different things. Let me take an example. I want to give more explanation regarding this. He gave duplex lab and 8-pole mission. For this he asked to find the number of armature parallel paths. Simple. A equal to, we know it is P into N. So P is 8, and what is the duplex number? For duplex it is 2. So number of armature parallel paths is 16. Done. If it is triplex wave with 4 pole, then we can write it as A equal to 2 times of N. Here 2 into what is the N? Triplex. So 3. So number of armature parallel paths is 6. Done. Where is lap and where is wave used? Lap is used for high current, low voltage generators. Lap is used for high current and low voltage generators, whereas wave winding is used for high voltage and low current generators. These are also two more important points. This is EMF generated formula. We have seen how to calculate, and we have seen simplex lap, simplex wave. We have seen multiplex lap, multiplex wave. We have seen some examples, and we have seen some more important points from lap and wave. Right? Then let us move to the next question. In a steam power plant, flue gases. Okay, sorry, I thought flux. Okay, fine. Flue gases do not pass through. Okay. Economizer. It is called feed water heater. It is also called feed water heater. So the feed water which is coming out from the condenser will be passes through that feed water pumps and all. Through that it will go to that economizer, and this economizer will heat the feed water by using heat from flue gases only. So this is not correct answer. Then air preheater. Air preheater, this will it will drag some air from external force draft fans. It will drag some air and it will heat the air through flue gases only, through the heat from flue gases only. So it is not correct. Then superheater. Superheater will also convert wet steam to dry steam, wet steam to superheated steam. This is done by using the heat from flue gases only. So all these will have flue gas effect, but condenser will never have flue gases. Flue gases will never pass through conductor. So the correct answer here is condenser. Remaining all will use the heat from flue gases, but condenser will never use the heat from flue gases, because the function of condenser is to convert that exhaust steam into condensate or water. So here we are reducing the temperature of steam to water, but here in all these three cases we are increasing the temperature. So please do remember, condenser is used for converting exhaust steam to condensate. So we never use flue gases here. And also one more point, in the entire thermal power plant or steam power plant, lowest pressure is maintained, least pressure is maintained in a condenser. So this is also one more important point. So we have seen 3, 4, 5 points, 6 points here. So you make use of it. Next. Done. So these are some of the questions from question series 2. And please, if you like this session, please do share this session. Please do share, please do comment, please do let me know for which you are waiting for. Not for physics sessions and all. For any other objectives and all, if you are waiting, please do let me know. I'll try to do them also. Right? Thank you.